let's open up another one here. So I'm going to call this one, let's see, let's call it Python script.py, or we can just call it python.py. Python. User bin Python. We can use which Python, and that will tell me that it's at user bin Python. That's where my Python interpreter is. So nano python.py. And again, we want to give it an interpreter. This is going to be an interpreted language as opposed to compiled. And the last thing we'll do is C, which is compiled. So for this one, we just need to give it an interpreter. As long as the system has a Python interpreter, which chances are if it's a Linux system it does, then it will be able to run this. So we want hash bang user bin Python. Alright, so this time we're going to do a basic little port scanner. Very basic. We'll see some much more intelligent port scanners when we move into port scanning later in the course. We'll look at kind of a basic, simple example here. So what we're going to do is see whether a port is open or closed. So we talked briefly about ports, and I mentioned I once had a boss who thought ports were actually those slots on the back of the machine, which certainly wouldn't go very far with our small machines we have today. In fact, your phone has the ability to make TCP/IP sockets using ports, so that would certainly make for a big phone. So they are just going to be network sockets. We make them with pieces of code just like this, in fact. So a typical exercise in programming, and certainly one you could try if you want to continue and learn some more, is to set up a simple web server in your programming language of choice, so be it in C, Python, even, we're not going to do a Ruby example here. We will see a little bit of Ruby in the exploit development, but it is, I think I had to do it in school. It was like make it serve a web page, make it serve a JPEG, make it serve a GIF, things like that. So you set up a listening socket and serve pages, so a little bit more advanced than what we're doing here, but that would be a good next exercise. So let's go ahead and set up a little port scanner here. So this time we're going to take some user input not from the command line. So in the last one we had a command line argument. You can do that here in Python as well, of course, but this time we're going to do things a little bit differently. We're going to take input from the user just with a prompt. The first thing I want to do is import a library. We didn't have to do that with our bash script, but basically what we want to do is say import and tell it we want the socket library. So that way we don't have to do all the underlying code of how to set up a network socket for our port scanning. There's already a library in Python that knows how to do this. We can use that as a building block to make our lives much easier. So we always want to use stuff that we can rather than reinventing the wheel, because otherwise we'd be here all day for sure, particularly as beginning programmers. Alright, so now we want to do a variable. We haven't seen a variable yet. Basically what we want to do is have a variable of whatever name we want and set it equal to a value. So it's basically a way to store data. So let's just call it IP. It is going to be the IP address, so that's a good name. So I'm going to create the variable called IP and set it equal to something called raw underscore input. Again, that's a Python construct. You can Google it to find out more about it, but it's just going to take input from the user. And I'm going to tell the user enter the IP address. So when this runs, it will prompt the user, enter the IP address, and whatever they respond with will be stored in that IP variable. So by storing it in the variable, we'll be able to use it later in the program. And let's also do port. So we want an IP address and port. So another variable called port, set it equal to. This time we're just going to do input. We want port to be a number, and then IP address is actually going to be a string. That's just how the connection works. And so we'll just do enter the port number, and then we have a socket. Let's not do the socket just yet. let's do that next. Let's actually see this run first. Let's not get ahead of ourselves. So again, we want to do our chmod. This time let's do +x python.py, run python.py. This time we don't need a command line argument. It does ask us for the IP address. I'll give it the IP address of my Windows XP system, 76, and port is 80. Well, that's all it does at this point. So it does prompt us, and it is going to store those two values for us. Alright, so now let's set up the socket. So, again, we have that socket library, so we can look up how to do this. This is one of those things that if you don't use it a lot, you'll probably have to look it up. So I'm just going to set sock, so another variable. So sock equals socket.socket. Yeah, because that totally makes sense. Parentheses socket.af_inet. So this is going to be a TCP socket. You can also make UDP sockets. One of our exploits in exploit development will actually be over the UDP protocols. So it'll actually be trivial FTP, so UDP port 69 rather. So we will see how to make a UDP socket as well. It's just a little bit different. So that is our syntax right there. And again, don't feel bad if you have to look that up unless you're doing a lot of Python programming. I mean, even if you take a break from it, you may have to look that up. So now we want an if statement here as well. So just like we did in the bash script, except the syntax is going to be a little bit different. I think a lot easier to work with. I don't think the syntax in bash scripting is that intuitive, whereas Python is a bit more intuitive, I think. But really it's a personal preference, what programming languages you like the best. Everybody seems to have their own opinion. So in this one we just do if, and we don't need any braces or anything. So if sock.connect. So I would think it's .connect. Typically we do use .connect. There actually is another option. So if we look at Python connect _ex. Here's some Python documentation about socket, exactly what we're after. So we look at connect. So this is the typical construct that's used for connecting. So connect to the socket to a remote address. For IP sockets, the address is a pair host port. Right under it, we have connect _ex, which is the one I mentioned. It's like connect, but it returns an error code instead of raising an exception when an error occurs. So if it isn't able to connect, connect will actually throw an error, so we would have to handle the exception, or else the program would crash, and that's not good. But with connect _ex, it looks like it'll throw an error code, so it won't do an unhandled exception. We won't have to do any error handling. It'll just give us a specific error code. So if our goal is to see whether or not the port is open, these error codes might be ideal rather than crashing it with connect. So let's try connect _ex. If sock.connect _ex, and we want to give it with double parentheses around it, IP and port. Remember, we asked the user for IP and port. We're giving it the IP address and port to connect to. We want a colon, so that's going to be our if statement. And what's interesting about Python is that it actually takes indentation as law. It actually denotes loops with indentation. So as long as we are indented, this would be part of our if statement. This, however, that's not indented would not. Of course, both of those are rubbish and not real commands, but you've got to be careful with your indentation. But it also makes it pretty easy to read. You can really tell where your loops are with the indentation, but you just can't get off with your indentation or else you'll have a mess on your hands. So if the connection works, so if it's true, which true is going to be anything non-zero, so any error code that we get is going to be true. So if it's true, I want to print out port, and port is closed. So what is this here? So we're going to print out to the screen, print the word port, because this has quotations around it, so that's going to be a literally string port. Then we tell it we want port. Remember, port is a variable, so it's going to take the value of port, and then it's going to print out is closed. So if we do get a positive error value, that means the connection was not successful, so that port is closed. So we're going to print out that port is closed. Alright. We also have an else statement here, and again we want colon to denote the beginning of our ifs and else statements here. And again, indentation matters. We need to indent. We need to make sure our else is right against column 0, but we do want to indent the else. So if we get a 0 back instead of a positive value, we want to print out port is open. So pretty primitive. You know, it only takes one port and checks whether it's open or closed. Certainly we'll see we can do much better, but it's something. It's a good little exercise. Now let's run it. IP address 192.168.1.76 in my case, and port 80. It says port 80 is open. Run it again. Port 81. Port 81 is closed, so it looks like my Windows XP system has something listening on port 80. Perhaps a web server. 80 is typically where web servers listen, but nothing on port 81. I can't think of anything in particular that listens on port 81, so that's not too surprising. Looking at a little simple example here. Not too much going on, so I encourage you to spend more time with Python as well. Again, we'll see Python when we get to our exploit development. And some of the tools we'll look at have been written in Python. It is a pretty big language for information security. Alright, so last little bit on programming, and then we'll actually move on to pen testing, what we're here for. We are going to look very, very briefly at the C programming language. Hopefully not too many security tools are written in C, but your operating systems, a lot of them are written in C. So, like your Linux is written in C, Windows does a lot of stuff in C, like your Android is all in C, iPhone is too, honestly. Well, the underlying system is anyway, some of it. So, you've got a lot of C out there in terms of like the platforms you're going to run into. Unfortunately, C is one of those ones, and it does have a tendency to have security issues with memory corruption based on some sloppy programming. So I guess that's good for us bug hunter types. Let's look very briefly at C, but again, I don't encourage you to use C to actually write your security tools, but more power to you.